According to the 2005 National Electrical Code, your proposed approach is permissible. However, it's crucial to acknowledge that the NEC has undergone several updates since 2005. Therefore, this approach might not align with the current code. In the 2005 NEC, Section 250.130c necessitates a ground fault path for all 120-volt single-phase, 15 and 20 ampere receptacle outlets. Section 406.3d3 permits the utilization of a GFCI receptacle to offer ground fault protection for existing two-prong receptacles. Figure 250-178 illustrates a scenario where a GFCI receptacle is installed upstream of a non-grounded receptacle. Your suggested approach involves firstly, replacing the existing two-prong receptacle with a GFCI receptacle, secondly, extending the circuit to the new bedroom receptacle downstream of the GFCI, and thirdly, protecting the circuit with an AFCI breaker. Note that the AFCI breaker is not mandated by the NEC but is advisable for enhanced safety. The current NEC, specifically the 2023 edition, introduces some modifications to the requirements for ground fault protection and AFCI protection. Section 210.8 AFCI mandates that all 120-volt, single-phase, 15 and 20 ampere receptacle outlets must be safeguarded by either GFCI or an AFCI. Additionally, Section 210.12c stipulates that all bedroom receptacles in dwelling units must be protected by an AFCI. To guarantee compliance with the current NEC, upgrading the existing circuit is recommended to fulfill the following prerequisites. Replace the existing two-prong receptacle with a GFCI receptacle. Install a new AFCI breaker in the panel board. Ensure all bedroom receptacles are protected by the AFCI circuit. Let's delve deeper into the technical aspects of GFCI and AFCI protection in electrical circuits. A ground fault circuit interrupter, or GFCI, is a safety device designed to protect individuals from electrical shock. It works by monitoring the current flowing into and out of a circuit. In a properly functioning circuit, the current flowing into the circuit should equal the current flowing out. However, if a ground fault occurs, meaning that current is leaking to ground through an unintended path, such as a person touching a live wire, the GFCI will detect this imbalance and quickly interrupt the circuit, typically within milliseconds, preventing serious injury or death. GFCIs are commonly installed in areas where there is a high risk of electric shock, such as bathrooms, kitchens, garages, and outdoor locations. They are often required by electrical codes in these areas. When dealing with older two-prong receptacles, which lack a grounding conductor, a GFCI can provide a significant level of protection. By replacing the two-prong receptacle with a GFCI receptacle, or by installing a GFCI breaker that protects the entire circuit, you can protect against ground faults that might occur if someone were to come into contact with a live part of an appliance or electrical device plugged into the receptacle. It is important to note that a GFCI does not correct the underlying issue of the lack of a grounding conductor. It simply provides a layer of protection against ground faults. An arc fault circuit interrupter, or AFCI, is another type of safety device that is designed to protect against electrical fires. AFCIs work by detecting arc faults, which are dangerous electrical discharges that can occur when there is damaged or deteriorated wiring, loose connections, or faulty appliances. These arc faults can generate intense heat, which can ignite nearby combustible materials and start a fire. AFCIs are designed to distinguish between normal arcs that occur during the operation of switches and appliances and dangerous arc faults that indicate a problem. When an AFCI detects a dangerous arc fault, it quickly interrupts the circuit, preventing the arc from escalating into a fire. AFCIs are typically installed in the electrical panel and protect entire branch circuits. They are often required by electrical codes in bedrooms, living rooms, and other areas where there is a high risk of electrical fires. In the context of upgrading electrical circuits with GFCI and AFCI protection, it is essential to understand the differences between these two devices and how they work together to provide comprehensive safety. A GFCI protects against electric shock by detecting ground faults, while an AFCI protects against electrical fires by detecting arc faults. In many modern electrical codes, both GFCI and AFCI protection are required in certain areas of the home to provide a layered approach to electrical safety. When upgrading an existing circuit with a two-prong receptacle, you may choose to replace the receptacle with a GFCI receptacle and also install an AFCI breaker in the electrical panel to protect the entire circuit. This combination of GFCI and AFCI protection can significantly reduce the risk of electric shock and electrical fires. When installing GFCI and AFCI devices, it is crucial to follow the manufacturer's instructions and all applicable electrical codes. It is also recommended to have the installation performed by a qualified electrician to ensure that it is done safely and correctly. Regarding the specific question about which modern brand of AFCI breaker can be used in a Brian panel board, it is important to consult with a qualified electrician or electrical supplier to determine the appropriate breaker for your specific panel board. Different brands of breakers may have different compatibility requirements, and it is essential to ensure that the breaker you choose is compatible with your panel board and meets all applicable safety standards. Furthermore, the National Electrical Code provides detailed requirements for the installation of electrical equipment, including GFCI and AFCI devices. It is essential to familiarize yourself with these requirements and follow them carefully to ensure that your electrical system is safe and compliant. In addition to the NEC, local electrical codes may also have specific requirements for GFCI and AFCI protection. It is important to check with your local building department to determine the applicable codes in your area. When upgrading an electrical circuit with GFCI and AFCI protection, it is also a good idea to inspect the wiring and other components of the circuit to ensure that they are in good condition. Damaged or deteriorated wiring can increase the risk of electrical shock and electrical fires, so it is important to address any issues before installing new safety devices. This inspection may involve checking the insulation on the wires, tightening any loose connections, and replacing any damaged receptacles or switches. If you are not comfortable performing these tasks yourself, it is best to hire a qualified electrician to do the work. They can properly inspect the circuit and make any necessary repairs or upgrades. In some cases, it may be necessary to replace the entire circuit if the wiring is too old or damaged. This can be a more expensive option, but it is often the safest and most reliable way to ensure that your electrical system is up to code and provides adequate protection against electrical hazards. When planning an electrical upgrade, it is also important to consider the future needs of the circuit. If you anticipate adding more electrical loads to the circuit in the future, such as new appliances or lighting fixtures, you may want to upgrade the circuit to a higher amperage rating to ensure that it can handle the increased load. This may involve replacing the existing breaker with a larger breaker and upgrading the wiring to a larger gauge. Again, it is best to consult with a qualified electrician to determine the appropriate size and type of wiring and breaker for your specific needs. In summary, upgrading an electrical circuit with GFCI and AFCI protection is an important step in ensuring the safety of your home or building. By understanding the differences between these two devices, following all applicable electrical codes, and having the work performed by a qualified electrician, you can significantly reduce the risk of electric shock and electrical fires. Firstly, consider the current NEC and local codes. Secondly, understand GFCI and AFCI functionality. Thirdly, inspect existing wiring and components. Fourthly, address any damages or deterioration. Fifthly, plan for future electrical loads. Sixthly, consult with a qualified electrician. Seventhly, follow manufacturer instructions. Eighthly, ensure proper installation and testing. Ninthly, maintain regular inspections. And tenthly, prioritize safety above all else. Let's now discuss specific scenarios and applications where GFCI and AFCI protection are particularly important. In bathrooms, GFCI protection is required for all 120 volt, 15 and 20 ampere receptacles. This is because bathrooms are wet locations, and the risk of electric shock is higher when people are using electrical appliances near water. Common bathroom appliances that can pose a shock hazard include hair dryers, curling irons, and electric shavers. By installing GFCI protection, you can significantly reduce the risk of electric shock if someone were to drop an appliance into water or come into contact with a live part of an appliance while their skin is wet. In kitchens, GFCI protection is required for all 120-volt, 15 and 20 ampere receptacles that serve countertop surfaces. This is because kitchens are also wet locations, and there is a higher risk of electric shock when people are using electrical appliances near sinks and other water sources. Common kitchen appliances that can pose a shock hazard include toasters, coffee makers, and blenders. In garages, GFCI protection is required for all 120-volt, 15 and 20 ampere receptacles. Garages are often damp or wet, and there is a higher risk of electric shock when people are working with power tools or other electrical equipment in these areas. Outdoor locations also require GFCI protection for all 120-volt, 15 and 20 ampere receptacles. This is because outdoor locations are exposed to the elements, and there is a higher risk of electric shock when people are using electrical appliances in wet or damp conditions. Common outdoor appliances that can pose a shock hazard include lawnmowers, power washers, and electric grills. In addition to these specific locations, AFCI protection is often required in bedrooms, living rooms, and other areas where there is a high risk of electrical fires. This is because these areas often contain combustible materials such as furniture, bedding, and curtains, which can easily ignite if an arc fault occurs. By installing AFCI protection, you can significantly reduce the risk of an electrical fire. When installing GFCI and AFCI protection, it is important to choose devices that are listed by a recognized testing laboratory, such as Underwriters Laboratories or all. This listing ensures that the devices have been tested and meet certain safety standards. It is also important to follow the manufacturer's instructions carefully when installing these devices to ensure that they are properly wired and functioning correctly. After installing GFCI and AFCI protection, it is important to test the devices regularly to ensure that they are still working properly. GFCIs can be tested by pressing the test button on the receptacle or breaker. This should trip the device and interrupt the circuit. If the device does not trip, it may be faulty and need to be replaced. AFCIs can be tested by using a special AFCI tester, which simulates an arc fault. This should trip the device and interrupt the circuit. If the device does not trip, it may be faulty and need to be replaced. Regular testing of GFCI and AFCI devices is essential to ensure that they are providing the intended level of protection. It is also important to be aware of the limitations of these devices. GFCIs and AFCIs are not a substitute for safe electrical practices. It is still important to avoid overloading circuits, using damaged electrical cores, and touching electrical appliances with wet hands. By following safe electrical practices and installing GFCI and AFCI protection, you can significantly reduce the risk of electrical shock and electrical fires. In addition to the technical aspects of GFCI and AFCI protection, it is also important to consider the cost of these devices. GFCI receptacles and breakers are typically more expensive than standard receptacles and breakers. However, the cost of these devices is relatively small compared to the potential cost of an electrical shock or electrical fire. Investing in GFCI and AFCI protection is a wise decision that can provide peace of mind and protect your family and property. Finally, it is important to remember that electrical codes are constantly evolving. It is essential to stay up to date in the latest code requirements to ensure that your electrical system is safe and compliant. Consulting with a qualified electrician is a good way to stay informed about changes to the electrical code and to ensure that your electrical system meets all applicable requirements. By taking these steps, you can help to create a safe and electrically sound environment for yourself and your family.